What do you think that would be? What's the next like revolutionary rocket? What's going to
See,
be in that?
okay, if you're asking what the revolutionary rocket would be, but you're still asking it still must be a rocket, then I don't know if there's that much advance. Like if we're still keeping our design with what we have right now, like the fact that there's some fuel being transmitted to an engine, the engine is,
Yeah.
expelling the fuel to move forward. That idea, oops,
Or maybe okay,
sorry.
maybe not the next revolutionary rocket, but like the next brilliant idea that will change
To be
space
honest,
flight.
actually continuing on that question, I could give you an answer like this. There are some fuels that have been hypothesized that could, as you very well mentioned, revolutionize rocketry forever. For
Why?
example, deuterium, which is one of the isotopes for hydrogen, is not actually commonly found anywhere. but if we can make a stable form, I believe, yeah, it's deuterium that provides almost that unlimited energy, right? Because I think the next best thing, okay, so the best thing that we could ever hope for would be metallic hydrogen, right? If we can use metallic hydrogen, which is basically hydrogen in its solid form, which has been hypothesized to exist, at the core of stars. No, core of the Earth? Core of stars.
I don't
Core of
know.
stars? Wait. Is it core of the
It
Earth?
doesn't matter.
Anyways, core of something. Basically a very pressurized region for this metallic hydrogen to exist. Metallic hydrogen could actually provide us with almost limitless power.
Wow.
So using metallic hydrogen, we could actually power an engine. And obviously, I don't know the very specific details, but I do know the rough idea. And it's very similar to deuterium as well. Basically, elements that we can't really find. And it will be able to provide very, very, very long travel journeys. So basically, the fuel will be able to continue to burn for extended times. And it would not be, it would basically not. How do I say this nicely? The ISP is a lot higher. The specific impulse, that's the technical term. That means the engine can run a lot longer on the same amount of fuel. That's the best way to put it. That's actually a nice way to put it. So that would be actually the revolutionary rocket phase if we were to get something like that. And that would be pretty crazy. I'm
So
thinking about a rocket like that.
I'm not sure how achievable this is.
Yeah.
But let's talk about the space elevator, okay? And why this would revolutionize rocket flight, okay?
Okay,
So,
I want to hear this.
So the space elevator,
Yeah.
okay? This is the idea. You have a cable that is tied down to the earth, and there's like kind of like a docking module at the end of the cable, and that module is outside of the atmosphere, or I guess into the stratosphere, something like that, such that like the angular momentum of the earth will actually keep that rope nice and tight, and then it'll keep the module just like in space, right? You see what I mean? You see, right? Like the centrifugal force will keep it out into the stratosphere. Okay, but here's the idea. What you do is that you tie like some type of elevator to that rope that will like climb up and down the rope. And what you do is you bring your rockets up to the docking module, and then you launch from there, where there is less gravitational force, which makes it easier to actually leave the Earth's pull.
No one cares about gravitational force, though. It's air resistance. That's the big problem.
Okay, well, air resistance and also because right, the further away you are from sea level, for example, the less you actually have to deal with, like using up your fuel. Of course, to get up the rope, you're gonna need, or you can use like electrical energy, for example.
Mm-hmm.
But once you're there, you don't need to spend or to use your fuel to get up to that point, to get past the air resistance, the gravitational and like
Yeah,
want to
I
say
know.
like
I totally know what you mean because I
wait, no, but
actually
what's
have
that
read.
word though? I was looking for a word. I like glitched for a second. The gravitational potential energy, right? That you have
Okay.
to convert
Yeah.
to
Yeah.
what
So
I meant.
I actually read a very similar article. Maybe we read the same thing, or maybe saw a video on it where it was talking about this exact thing, where the future of rocketry truly would be if we can, or not future of again, just like a shortcut would be if we can kind of push our rockets to the level of space and then we can launch it from there. Because on average, I mean, obviously this number might not be very, I mean, I'm just around 30 to 40%. I think that's a very reasonable number. A very big chunk of your rocket's fuel is being used only to get out of Earth. Is only used to get out of Earth.
Which
so
makes
interesting
sense if you think about it, right?
Sorry?
Because once you're in space,
Yeah.
you're just cruising.
Yeah, once you're in space, you're cruising. Once you're in space, you're cruising.
You
You
need
just
to
need
do
to
some
get there.
adjustments, but you know, you're already going.
To get into orbit, right? The average orbital velocity is about 8 kilometers per second, right? Around that speed. Depending on the height, obviously it can vary, but 8 is a very general number. So that means that the rocket would have to reach 8,000 meters per second by the time it's in orbit. And now remember, because of air resistance and because of, well, gravity is an obvious factor, but air resistance is the biggest one, because of the atmosphere itself, right? Because if there was no atmosphere like the moon, we would have no problem. Shoot up, perfect. But because we have an atmosphere, very unfortunately, well, fortunately because of the UV rays, but anyways, because we have an atmosphere, we have to get out of it, and getting out of it is the biggest problem. So if we could actually make this space elevator to get a rocket all the way up there and then launch it, it would be cool, but here's the problem. Now, here's what I was thinking about while you were saying that stuff. Now, the biggest question is, well, first of all, how high do you propose the space elevator would be? Would it be all the way to geostationary orbit?
Well, okay, I don't know the specifics here, but
like, would it just be to, like, 200, 300 kilometers above?
Ideally, you would put this into a multivariable function and you solve for the maxima, right? To get the best
well, we
bang
don't
for
have a
your
lot
buck,
of variables
right?
here, though. Remember that, because the biggest problem with this is,
no,
remember,
we do actually. No, we do, because one, you need to consider the energy it takes to actually transport up to the... Two, also building materials.
That's the thing. That's another thing. We don't actually have
stuff.
that yet. We don't have building materials that are strong enough to actually withhold all of this.
I know, but if we were in like we were hired to plan this out and say, okay, we'll figure out the ideal height that will in the long term will save us the most money, then we have to take into consideration like the height of the elevator, the materials.
No, but see, now let me pose this. Now let me pose this this kind of con question, like this opposing question here, and this is where a lot of people are like, well, you know what? I see why we don't need one. The space elevator is very expensive. Very expensive. It costs, I think, around like $15 or something billion to build, right?
Which so actually.
Sorry?
15 billion. You can get that from Musk.
Okay,
if you
relax.
have a nice pitch,
I'm not gonna start donating a space elevator.
If you have a good pitch, you know.
I'm gonna donate you a space elevator.
To him.
Okay. Anyways, that's not the point though. The point is that it would take materials that we don't even have yet to make such a thing, right? And to actually get this rocket all the way there. Like, these are all just questions. These are all not questions. These are all just theories that we have. That, it could happen like this. It could happen like this. But we don't know. And I don't think we ever will know until we actually, allocate resources for building such a thing.